All right, so here we are going to apply some of the new theorems that we learned about. So we have angle, angle, side, angle, side, angle, side, 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 and side, angle, side. For normal triangles, I guess normal is a weird way to say that, but then for right triangles we have hypotenuse, leg. So we have those 5 different things that we can use as information to prove that these 2 triangles are congruent. So in this activity I want to state whether the 2 triangles are congruent, and then if they are, state how we know. So basically just using one of these 5 things, how can we verify that they actually are congruent? So throughout this, we are going to be using vertical angles and the reflexive property. So in addition to what's actually marked in these pictures, we can use vertical angles and the reflexive property just to easily jump to having another pair of either congruent sides or congruent angles. So in this first picture, actually that is when I'm going to use the reflexive property. I know that this side is a part of this triangle, and by the reflexive property I know that it's congruent to itself, so it can be used as a congruent part in that triangle and in that triangle. I'm going to redraw this triangle outside of that picture. So I have this angle, this side that's congruent between the 2 triangles, and this side that's congruent between the 2 triangles. So when I'm reading these, I'm really thinking about this if it's sandwiched in between 2 A's, or this if it's sandwiched in between 2 S's like that. It's the included side or the included angle. This is a non-included side because it's not actually squeezed in between the 2 angles. So here I have a non-included angle and 2 sides that are next to each other. So I have a side, and a non-included angle. That is not something that proves that these 2 triangles would be congruent. So we cannot use that logic. I'm going to just say that we really can't prove that these are congruent. Obviously they do look like they're congruent, so I don't want to just say that they're not congruent. Can't be proven, let's just say that. Because that logic doesn't actually tell us, it doesn't really confirm it without a doubt that those are congruent triangles. Number 2, I'm going to use the reflexive property again. I'm looking at that side as a shared side between those 2, and it's the included side between those 2 angles. So we have angle, side, angle, verifying that those are congruent. On this next one, I'm using the reflexive property again. That side is shared between this triangle and this triangle, so it is congruent to itself and a congruent part between the triangles. And so are all of the other sides. We have 3 congruent sides, verifying that those must be congruent triangles. On number 4, I have this angle, that side, and these are vertical angles, so they must be congruent also. Let's put 2 on that to show that it's not necessarily the same as that. But these are congruent to each other, these are congruent to each other, so I have an angle, a side, and that next angle over, this is the included side, so actually I have the same exact logic again. Angle, side, angle, showing that those 2 have to be the same triangle. The next one, I only see 2 markings here. I have an angle and its opposite side. The only thing that uses just 2 pieces is hypotenuse, leg, and that doesn't seem like I have right triangles there, so I'm going to say nope, can't be proven. Alright, and then number 6, I have a right angle. Actually, I also have vertical angles here. So I can show this in 2 different ways. I have an angle, the included side, and another angle. So I could use angle, side, angle, angle, side, angle, angle, side, angle, although I did that in the opposite order. I could also use hypotenuse, leg. I have, well, no, I can't use hypotenuse, leg. Sorry, I don't know that those are congruent. I would need to know that the hypotenuse of those triangles is congruent. Nope, I can only use angle, side, angle there. But that shows that they are congruent. Alright, this next part, I'm going to state the missing piece of information. So we want to state whatever additional information is required to say that these 2 triangles are congruent by that logic. So I have a shared side there. I have an angle here and here. So I would really need to know that the next angle over not this one, because the side is included in those angles. I need to use this angle and this angle. So I would need to say that angle DUT, that angle, is congruent to angle SUT. If I had that piece of information, then I would have angle, side, angle. All right, on this one, I need side, angle, side. So I have a side here that's shared between them. And then I have the next angle over, so I'm looking at this triangle, that side, that angle. And the next side over is really what I would need. I would need this side to be congruent to that side, because I need the included angle between these two sides. So I would need VW or WV to be congruent to XK. Right here I'm looking for side, angle, side again, so I'm looking for this side and this side to be congruent, then the next angle over, and the side that would include that angle. So this is the included included angle between these two sides. So really what I need to show is that these two are congruent to each other. So CA would need to be congruent to JL or LJ to have the three pieces that I need there: the side, the angle, and the side that would include that angle. Same thing here again. I'm looking for an included side. I'm looking for an angle, another angle, and the side that's in between them. So I would need this to be congruent to, again, it's the side that's in between those two angles. So DE needs to be congruent to KJ or JK.